guys, welcome to your last chapter. It's very exciting. Whoop, I don't know what the camera's doing. This is kind of like what I call the hodgepodge chapter, just because it's a bunch of random, not really random stuff, but it's a lot of like application-y kind of stuff. Actually, a bunch of it you should feel really comfortable doing just because it's a lot of review, because it has a lot of formula. So we're actually looking at our formula sheet for the first time this year, which is exciting. Yay! You get to see what you can use on your SOL. So let's dive right in. On your notes, you'll notice that I provided with you your formula sheet. The first part of the notes is actually just practicing, like, how do I read this? What are some things that are on it? So if you look through, it's got a bunch of formulas for you that you can use. This is something that you can ask for, paper copy or an electronic copy on your SOL. So make sure that you look through this and apply it with those first couple of problems. Here's the back side if you notice. Look what's on there. It's got Pythagorean theorem, which is your favorite formula in the entire world. It's also got your sine, cosine, tangent. I know it's a little hard to see on this screen, but you have it on your paper. It has all the setup. It doesn't set it up the way we have talked about it in class, like the nice and pretty, like SOHCAHTOA stuff. But it does give you kind of like a layout on, okay, here's a reminder. Here's where you find your sides. The other thing it gives you is that formula for your circle, which you had to memorize last chapter. So it would be nice that you don't have to memorize that anymore. Okay? So this is your formula sheet. Get used to it. On this next test, you're going to be able to use it. But don't rely on it heavily just because questions aren't normally going to be about, like, hey, plug these numbers into a formula. It's going to be more application. So if you look at the next page, I gave you some practice. So just practice using that formula sheet, okay? That's like the whole purpose of this first sheet. I am expecting that you'll be able to finish it all. The only one that you won't know how to do was a rhombus or a kite. Those two, I will give those to you during class. So these ones are the only ones up here, are the only ones that you won't have to do, as well as, number 4 down here. Okay, so we're going to go over that in class, just so you are aware. I don't know why this camera keeps. With that being said, let's just dive right into our notes. Again, make sure that you're jotting down questions if you have them. Okay. All right. So first section is going over circumference and arc length. Arc length we've kind of seen before. The only difference between this arc length and the next one we're going to talk about in a little bit is that arc length, in this respect, we're talking about the actual distance, like not a degree measure. So we're talking about in measurement in feet or in meters or something that's a little bit more hands-on and tactile. Circumference. That's on your formula sheet, so have that. What is the circumference of a circle? Like, what's that formula? Okay, so you saw a couple different ones. It was pi, 2 times pi times r, where r is our radius, right? The other one was pi times diameter. Okay, but what was a circumference? Okay, a circumference, what was it? Like, what did it mean? Yeah, it meant distance around the circle. So you can think of it as kind of like a perimeter, okay? And we always use real units. So like, again, meters, inches, feet, miles, something like that when we're talking about circumference of a circle. Something like that, okay? All right, arc length, we're only talking about a piece of our circle. So So if you wanted to think about it like in respect to pizza, because I'm always thinking about food. So if you think about pizza, if you cut yourself a slice, it's whatever crust you got. That would be an arc length, okay? Again, when we're talking about arc length in this particular unit, we're not going to be using so much of degrees. We're going to be using more of our real life units. So we're going to be using meters, inches, miles. So we're looking at an actual measurable distance, okay? Again, if you have questions on either of these words, just make sure you write down questions on your notes. Okay, moving on. Circumference of a circle, we already talked about both of these formulas. Remind yourself, what were they again? Good, 2 pi r, and the other one was pi times diameter. So make sure you fill both of those in on your notes here. Now let's actually use both of those formulas and try and find different pieces of our circle, okay? So for example 1, we wanted to find the indicated measure. So for part A, they wanted us to find the circumference of a circle when they gave us the radius, okay? So using that, we know r is going to equal 11. That's something that we're given. They want us to find c, or our circumference, okay? That's what we're finding. So because we have our radius, which circumference formula do you think we're going to use? Yeah, we're going to be using the one with the radius in it. Good job. So that's what's given right here. So circumference is equal to 2 times pi times r. In this case, we know what r is. We want to find c. So let's plug in 11. Well, because of multiplication, we can multiply numbers together before we multiply pi. So 2 times 11 is equal to 22. Okay. And then from here, you can either sometimes they're going to give you they're going to give you the answer in terms of pi. So from here, if they wanted it in terms of pi, you could have left it right here without multiplying anything else. If they wanted you to round your decimal, then you would have punched it into your calculator using 3.14 as your estimation. Once you do that, you should get 69.115 meters. Okay, again, whenever they don't tell us specifically how many decimals to round to, always just round to 3. Okay. All right. So for B, what was different about this one? Okay. So for this one, they wanted us to find the radius instead, and they gave us the circumference. So they gave us the circumference to be 18 yards. And they want us to find r. Okay? Again, since they want us to find r, which application of the circumference formula should we use? Yeah, the same one that we used before. Okay? So we have circumference is equal to 2 pi r, but this time, instead of plugging in for r, we're plugging in for c. So we have 18. Now from here, we can think of this as a regular equation. We just want to solve for r in this case. So this is the letter that we're solving for. So instead, how are we going to get r all by itself? Okay, so the opposite of multiplying would be to divide. So we have to divide both sides by this 2 pi, okay? So we want to get r by itself, divide by 2 pi, divide by 2 pi. Again, if I wanted to leave it in terms of pi, I could just simplify my coefficient. So my 18 divided by 2, which is equal to 9. And our pi was in our denominator, so 9 divided by pi would be in terms of pi. Okay, so all we did was we simplified that 18 over 2 and kept pi where it was. Okay. Otherwise, if they wanted it rounded, again, just like we were talking about before, you can punch that into your calculator, and you would use 2.865. Okay. So again, just use 3.14. as your estimation from here on out. You don't have to worry about finding the pi button or do anything like that. Just use 3.14 whenever you're plugging in for pi into your calculator. Okay? All right. Again, if you have any questions, make sure you're jotting them down. One thing I'm going to be really particular about with this particular unit is I am going to be looking for correct units. Okay, so make sure if they gave you a unit, make sure your answer has a unit as well. Okay, you will get points off if you don't have the correct unit. All right, so checkpoint 1, that's your practice problem. That's for basically you try. Go ahead and give it a whirl. Should be easy peasy lemon squeezy. Okay. Next one. So this arc length. Okay. So now we're going to talk about how can we find an actual measurement for an arc. Okay. So not a degree measurement, but a unit measurement. Excuse me. I'm sorry. This is like going crazy. Okay, so for these particular problems, we're going to be setting up a bunch of proportions, okay? Okay, so we're going to be setting up proportions, okay? This is the longer ways where you have your arc length, which is that actual measurement. So we're talking about the unit arc length over the circumference of our circle. Is going to be equal to the angle measurement over 360. Oh my goodness, this is probably the worst video ever. Okay, so another way that you can think about this is you can have units over circumference is equal to degrees over 360. Okay. Oops. And again, this was an arc length in units. So arc length in units over your circumference is equal to your degrees over 360. Okay. And it's going to make a little bit more sense when you see it actually doing it. Okay. So let's look at example 3 together. So for example 3, they want us to find the indicated measure. For the first one, they want us to find the arc length, so the actual unit measurement of AB. So they want this measurement. So yes, right now you're probably thinking, oh, this is a central angle, so it's 80 degrees. Well, for this particular problem, they want us to actually find the measurement in our units, which in this case is meters, okay? So we have to set up a proportion in order to find that actual tactile measurement, okay? So from here, let's use this formula up here that we just talked about, or a proportion. So the first side is talking about arc length over units. Well, they told us that they want us to find the arc length. So that's actually going to be, this first part is going to be x, okay? Over our circumference, which our circumference formula I gave to you up here is 2 pi r. What am I given in my picture? I'm given a radius. Good. So I can just plug this into my circumference formula. So I've got 2 times pi times my radius, 2, is equal to my degrees over 360. Well, I have 88 degrees, so I can plug that in over 360. Okay? All right, then from here, all we need to do, we set up a proportion, all we need to do is cross multiply. If before that you want to plug this 2 times pi times 2 into your calculator and get a rounded decimal, that's fine. Other than that, you can just cross multiply. So when you cross multiply, again, you're doing diagonal, so x times 360, which is 360x, is equal to 88 times 2 times pi times 2, which you can just multiply all together, and you end up getting 1,105.841. Again, I'm rounding to 3 decimal points because it doesn't tell me otherwise. So I've got my proportion, and then from here, what can I do to solve for x? I can divide by 360. So when you divide that by 360, again, round to 3 decimal points, you get 3.072. Am I missing anything? Yeah, good. Hopefully you're saying units, because we are missing a unit, and again, I'm going to be really particular about that, okay? Since we were finding an arc length, we were finding this actual measurement, okay? We're using our units, whatever our units were, which in this case were meters. So all we did is we found the measurement from A to B in meters, okay? So from A to B, it's going to be 3.072 meters, okay? And there's our answer. Okay? Again, if you have questions, write them down. I would still like you to try the checkpoint, okay? Checkpoint 3 is going to be just like part A. Okay, let's look at part B. For this one, what do they want us to find? Okay, hopefully you are saying our actual angle measurement or our degree measurement rather than our arc length in units, okay? For this one, it's really poorly labeled, so I apologize. This 12.3 feet is going to be your radius, so from Q to S, or our radius, is going to be 12.3 or 12.3 feet, okay? So we have a radius of 12.3, good. This 38 is going to be that actual arc length from R to S in feet, okay? So this is actually going to be our arc length in units, okay? Is there anything else we're given that you can see? All right, so one thing to be careful of, even though this looks like this is the diameter, it actually isn't. When we set up our proportion and solve and find out that arc measurement, you'll actually see why it's not our diameter, okay? So let's start setting up our proportion. So we have our arc length in units. That was right here, so let's put that on the top of our first proportion over our circumference, okay? Do we have a circumference? No, but we can find it because we're given a radius. So let's plug our radius into our circumference formula. So 2 times pi times 12.3. Okay, is equal to, remember, degrees over 360. We already have the 360 part. But our degrees is what they actually wanted us to find. So that's going to be our x in this case. Okay. So again, from here you can plug this into your calculator and get a decimal, but we're cross multiplying. Okay. So 38 times 360 is equal to a big number, 13,680 is equal to that 12.3 times 2 pi times x, which is equal to 77.283 x. And again, I want to get x by itself, so what am I going to do with that 77 point junk? Divide it. Good. So to get x, again, round to 3 decimal points, you get 177.001. Oops, 011, excuse me. Okay. And for this one, what's our units? We were talking about a degree measurement, yes. So our answer should be in degrees. Okay? Again, if you have questions, make sure you're jotting them down. Part 4 is going to be just like Part B. So for your checkpoint problem that you're doing by yourself, make sure you refer back to Part B for that. Okay, so go ahead and try those 2 checkpoints, pause the video, write down your questions, whatever you need to do. Okay, next part of the notes, oops, sorry, I got a little cut off there. So the next part of the notes, we're going to be talking about the area of the circle. This one, it's going to be very similar to what we just talked about with sector. The only difference is that we're talking obviously about area. So with area, our area of our circle, it's going to be a little bit of a different formula. It's going to be pi times our radius squared. Again, not times 2, it's squared, okay? And again, whenever we're talking about area of a circle, we need to make sure we are careful with our units. So we're looking at real units, like meters and inches and etc. I feel like I really like meters and inches today. Okay. So from here, for example 1, they want us to find the indicated measure. For this one, they want us to find the area, and they gave us this radius of 4.2, okay? So our area formula is pi times our radius squared. Well, we were given our radius was 4.2 meters. So let's punch that into our formula. So we got pi times 4.2 squared. Well, order operation tells us that we need to make sure that we do that 4.2 first, that 4.2 squared first before we do anything else. So 4.2 squared, and then multiply that by pi afterwards, okay? After that, once you do that and make sure you are doing that correctly, you get 55.418, okay? Now, I said earlier that I need you to make sure that you are careful with your units, okay? Well, when we're talking about area, there was something special about the units, okay? Since we were talking about a 2-dimensional thing, we're not talking about just the measurement from point A to point B. We're talking about this actual space. We're talking about the space that it covers. Since it's talking about 2 different dimensions, our units are going to be whatever it is squared, okay? So for this one, since we were talking about meters, it's going to be meters squared, okay? Again, incredibly important. Make sure that you're really careful whenever you're labeling your units, okay? For part B, they want us to find the diameter, and they gave us the area, okay? Well, for our area formula, all we have is a radius. But what do we know about the radius and the diameter? Yeah, if we multiply our radius by 2, we get the diameter. It's equal to the same thing. So we're still going to use our area formula. Since we have an area, we're going to be plugging that in for A. So we have A is equal to 201 inches squared. We want to find R first in order to find D. So let's plug A in and solve for R. So we've got 201 is equal to pi times R squared. We want to get R by itself, so what's the first thing we need to do? Divide by pi. Good. So we've got R squared is equal to some decimal, which is 63.980. Is R by itself? No, not quite. How do we get rid of the squared? Think back to the Pythagorean theorem. Hopefully you're saying square rooting, because that's the opposite of squaring. So let's take the square root of both sides. You get R is equal to 7.999. And that's our radius. Are we done? Did we find what we need? No. we need to find the diameter. So what did I need to do with this radius? I need to multiply it by 2. Good. So if I did 2 times the radius is equal to the diameter, so 2 times 7.999 is equal to 15.998. Okay, am I good? Am I good to go? No, hopefully you're saying you're missing your units, Miss Smith, because I am. What is my units for this one? Is it inches or inches squared? It's only going to be inches, and the reason for that is because we're only talking about a distance or measurement. Okay. So this one was inches. Okay. Again, if we're talking about area, we're talking about space. When we're talking about distance, we're only talking about one dimension from point A to point B. Okay. All right, so go ahead and do your checkpoint below. That one's going to be just like B. So make sure you look back at that one. Okay. So, so far, we talked about circumference and area, and we talked about how to find the arc length of a circle. Next thing we need to talk about is a sector. A sector, all it is, if we want to go back to pizza, because I'm really hungry right now, think of the slice that you get and you get to eat, okay? So again, when we talked about arc length, we were talking about the crust. For a sector, we're thinking of the whole piece of pizza with all the good stuff with it, okay? So think of a piece of pizza, or it's a piece of the circle. And it's talking about the area of it, okay? So the sector is like the actual space or chunk that you took away, okay? So to find the area of this sector, we're actually using a very similar proportion as what we just talked about with arc length. The only difference is that we're talking, instead of having an arc length in the top of our first proportion, we are talking about the area of the sector instead. So this is going to be the area of the sector over the area of the circle, which is pi r squared, is going to be equal to our measurement. In this case, they're talking about A to B, but we're talking, again, we're using it degrees over 360 for that second part, okay? So again, area of sector over the area of the circle is equal to the degrees over 360. Okay. So let's talk about example 2, and I think this is actually the last one. Yay, you can stop listening to me talk. No, I have one more. I lie. I'm sorry. That was false advertising. So for here, find the area of the sector formed by angle RQS. So they gave us what two things in our picture? They gave us this angle measurement. What else? A radius. Good. So 5 was our radius. So we know that we can plug that into our circumference, or our area formula. That's 63 degrees. Where do you think that's going to go? Degrees is the key word. Hopefully you're saying degrees over 360. So 63 over 360 is the second part of our proportion. So again, we're finding this area sector, okay? So that we know is going to be our x. Do we have the area of the whole circle? Not right now. We have the formula and we have a radius. We can plug that into that. So we've got pi times 5 squared is equal to, that's 63 over 360, because we've got degrees over degrees. Okay? Okay? Just like we talked about for the last examples, we just want to cross multiply. Okay? So we're doing 360 times x, which is 360x, is equal to 63 times that pi times 5 stuff. That's equal to 4,948.008. Okay. And then again, we want to solve for x, so what do I have to do with 360? Hopefully you're saying dividing. So x is equal to what? Round to 3 decimal points. 13 point something, 744. Okay. Am I good? No. My units? We were talking about area of the sector, and that's using units, remember, our real live units. So for this one, what are our units? Did they give us any? No, they didn't give us any, which is kind of weird. So whenever they don't give you any sort of unit to label your stuff with, you can just write units. Real original, I know. And since we're talking about area, again, we're talking about space, amount of space something covers. So it's going to be units squared. Okay. If you have any questions, make sure you're writing them down. One more example to go through, yay! And then you have your checkpoint, and then you're done. Okay. So for this one, example 3, again, they want us to find, we're going to be using that sector area proportion somehow. But for this one, they want us to find the area of the entire circle, okay? So we know we're finding something different for this one. We know that we're finding the area of the circle, okay? And that was the bottom of our first proportion. On the top of that was our sector area. Were we given that? That's actually what this A is, okay? So the area is equal to 22 meters squared. So that is the area of our sector. So that's going on the top. It's equal to, again, that second proportion was degrees over degrees. Do we have a degree measurement in our picture? Yeah, 45. So 45 over 360. And then, what do I do next? Cross multiply. So 22 times 360 and x times 45. So we've got 45x is equal to something. $7,920. I think. Divide by 45, divide by 45. So then x is equal to, I think that's actually a whole number. Yeah, it is. 176. So our area of our entire circle is going to be 176 what? Yeah, that's going to be meters, but meters squared. Because again, we're talking about the area of the whole circle. Okay? So this comes to the end of our notes. Again, if you have any questions, make sure you're writing them down. Try checkpoint 2. This one is going to be just like example, the previous example. I think it was example 2. Yeah, example 2. Okay? So make sure you look back at that one if you need help. Okay? All right, I will see you in class.